Yes, hello. In this video, we're going to be considering how to use the truth table to prove some logical statements. Okay, for instance, we're told to show that a conditional statement P implies Q and contrapositive statement negation of Q implies negation of P have the same truth value. So solution. So let us take it from here. Let's have a column for P, a column for Q, K, and a column for P implies Q. Let's recall that in a conditional statement, okay, the only situation where we can have the statements to be false is when the antecedent is true and the consequence is false. So what's the antecedent? What's the consequence? The antecedent is the first statement, P, while the consequence is the second statement, Q. Okay? So we have P implies Q. We also call it hypothesis and conclusion. Okay? Like for instance, if P is the statement, a triangle is equilateral. And another statement, Q, is a triangle is equiangular. So P implies Q means if a triangle is equilateral, then it is equiangular. So that's the meaning of P implies Q. So now in a conditional statement, like I said, the only situation where we can have this column to be false is when the antecedent is true and the consequence is false. So let us just recall that. Okay, let us put some truth values and false here. We have T, true, false, false. So let's alternate them here. True, false, true, false. Now, true implies true. It's still going to be true because both the antecedent and the consequence are true. Okay? True implies false will be false. Like I said, the rule guiding conditional statement is that we only have false if the antecedent is true and the consequence is false. That's the only situation where we can have false. Otherwise, it's going to be true. That's why this place, false implies true, is going to be true, and false implies false is still true. So, now let us combine negation of Q and negation of P, because that's what we're looking for. Negation of Q implies negation of P, which is the contrapositive statement of the conditional statement P implies Q. So let us take negation of Q. That is, we're going to negate the truth values of each of these. So if we have true here, its negation is going to be false. If we have false here, so its negation is going to be true. Okay? If we remember, the truth table for negation is such that when a statement is true, its negation will be false, and when a statement is false, its negation will be true. Okay, so negation of this is going to be false here, and the negation of this is going to be true. Okay, so let us look at negation of P. So negation of this true here is going to be false. Negation of this true is going to be false, while negation of this false is going to be true, while the negation of this false is going to be true. So let us now have negation of Q implies negation of P. So how would that look like? So that means we are looking at false implies false. Okay? Both of them are false and false. So it's still going to be true. The only situation for conditional statement, this symbol is showing implication. So the only situation we will have is when the antecedent is true and the consequence is false. In fact, let me just, in a conditional statement, the only situation where we can have it to be false is when the antecedent is true and the consequence is false. The first statement is the antecedent, the second statement is the consequence. Where is this thing going to be false now? Let us look at it. We have true here, which is the antecedent, and we have false here, which is the consequence. So definitely it's only in this area that we are going to have false, because the antecedent is true and the consequence is false. Even if the antecedent is false and the consequence is true, we are still going to be having true. Even if both of them are forces, we are still going to have true. So true implies true as well will give us true. So if we observe carefully this column comparing with this column, we discover that they have the same what? Truth value. Okay, so we conclude that therefore from the truth table constructed, map this statement P implies Q has the same truth value as the contrapositive statement negation of Q implies negation of P. Thank you and God bless you. In the next video, we're going to be proving more of this.